Welcome to Mrs. Miller's notes for her double block algebra class. These are the notes for the section entitled Arithmetic Sequences. And today we're going to talk about how you can find a pattern and the next set of numbers in an arithmetic sequence. We're going to write an equation for the nth term of an arithmetic sequence. And then we're actually going to find any given term in an arithmetic sequence. Now, before we start talking about what a sequence actually is, I want to get you thinking about it with this opening activity. So you are stacking logs for firewood. The first row you make has 21 logs. Each of the following rows has one less log than the row before it. You're able to stack the logs 7 rows high. How many logs are there in each of the 7 rows? And how many logs are there altogether? So we have this nice picture that's drawn for us as well. It's got 21 logs going across the bottom. It's got 7 rows high. Now I'm not going to sit here and count every single log in that picture, but I am going to organize the information in this problem. And I'm going to use a table to do that. So I'm going to have my row and my logs, the number of logs. I'm going to organize that into this table here. So I have 7 rows in this stack of firewood. And then it said my first row had 21 logs, and each of the following rows had one less log. So my second row will have 20, and then 19, 18, 17, 16, and 15. So now I know how many logs are in each of the 7 rows. That was one question I had to answer. And now to find how many logs there are altogether, I'd have to add 21 and 20 and 19, 18, 17, 16, and 15. So when I do that, I'll get a total of 126 logs. So that's how many logs are in that big stack of firewood in that picture. Now notice there was a pattern that we were using to help us solve this problem. We were subtracting 1 every single time we added a new row in our stack of firewood. We subtracted 1 log. So that was the pattern we were using. That was our sequence that we were following. So that's what we're going to be working on today. And we also want to think of this pattern as a type of slope. And slope is a concept that you're familiar with. So this could be kind of a review or a preview of that concept of slope. But it's going to be a constant amount that we're either adding or subtracting to get these sequences. And that's really what slope is. It's adding or subtracting a constant amount to an equation. So before we get into specifics of our examples here, we got to go over some vocabulary. When we're talking about sequences, it's going to be a list of numbers in a particular order that follow a specific pattern. So it's kind of like our number of logs that we had in that previous table. We started at a specific number, and then we followed a pattern. We subtracted 1 every single time. So that was our sequence. Now, each number in the sequence is called a term. And the way we write that in math is a sub 1 will be our first term. A sub 2 will be my second term. I could keep going and say a sub 3 is my third term, a sub 4 is my fourth term, etc. So we're going to use those subscripts to tell us what term we're referring to. And we're going to talk about 2 different types of sequences this year. We're going to talk about arithmetic sequences and geometric sequences. So for now, the arithmetic sequence is a sequence in which each term after the first term is found by adding or subtracting a constant number. And that number is going to be called the common difference, or that's your pattern that you're following. And we're going to call that common difference D. and we are either going to add or subtract it to or from the previous term. So we're going to start with a specific amount, and then we're either going to add or subtract another amount to or from it. So arithmetic sequences always deal with adding and subtracting. So let's take a look at our first example, where we're just going to find that pattern, that common difference. Or in other words, we're going to find what we're adding or subtracting to go from one number to the other. And when you look at this sequence of numbers, you want to start on the left and work your way to the right, just like you're reading a book. So I'm going to think, how do I go from 52 to 49? What do I add or subtract to go from 52 to 49? Well, we subtract 3. And then ask yourself, how do I go from 49 to 46? I subtract 3. And they go from 46 to 43? I subtract 3. So that pattern is consistent, it's constant, it's the same every time. So that is going to be my common difference. That's my pattern. And you can write it as minus 3 like this, or you could write subtracting 3. I'll abbreviate it. Okay, now if we look at part B, we're going to approach it the same way. We're going to look at the sequence of numbers from left to right, and we're going to say, how do I go from the first term to the second term? What am I doing? What am I adding or subtracting to go from 0.5 to 2.5? Well, I add 2. To go from 2.5 to 4.5, same thing, I add 2. And from 4.5 to 6.5, again, we add 2. So that's going to be the pattern or the common difference. And you can write it in words, or you can write it in symbols. So hopefully that is something you're familiar with and able to do really, really well. Now in example 2, they're going to add another little step onto this. They're going to have you find the common difference and the next 3 numbers. So by common difference, that means we're going to find out what we're adding and subtracting to go from one number to the other, and then we're going to find the next 3 numbers in the sequence. So again, going from left to right, to go from 89 to 78, I would have to subtract because the numbers are getting smaller, and I'd have to subtract 11. 89 minus 11 would be 78. And then how do I go from 78 to 67? Again, we subtract 11. So that's going to be my pattern. I'm going to subtract 11. And now I want to find my next 3 numbers. So I'm going to do 67 minus 11, and that will get me 56. And then I'll do 56 minus 11. That's going to get me 45. And then I'll do 45 minus 11. That's going to get me 34. So you can write it like that, or you can write 56, 45, 34. Write it with the commas, kind of like our sequence looked. And then for part B, we can do the same thing there. You want to look at your 3 terms. And this might seem a little more intimidating because you have decimals. So if you need to, instead of trying to think, what do I have to add to go from 4.5 to 16.2, think, what would I have to subtract? If I'm at 16.2 and I take away 14.5, I'll get the amount that was added, which is 1.7. And same thing to go from 16.2 to 17.9. If you're not sure what was added, then subtract. Do 17.9 and subtract 16.2, and you should get 1.7. So that's how much you'd have to add to the 16.2 to get the 17.9. So that's going to be my common difference. I'm adding 1.7 every single time. So in your homework, you might have some whole numbers that you're adding or subtracting. You might also have some decimals that you're adding and subtracting. It's okay. So then to find my next set of numbers, I'd have to do 17.9 plus 1.7, and that's going to get me 19.6. Then I'd have the 19.6 plus another 1.7. That's 21.3. And then if I add 1.7 to that, I'll get 23 or 23.0. So those are the next three numbers in my sequence. So again, this is a concept that should be fairly straightforward. It might seem a little tricky with your fractions or your decimals, but remember you can add if you're going forward, or you can subtract and go backward too to figure out what they have to add or subtract. Okay, now there is a way, there is a pattern in the way that the terms of the arithmetic sequence are formed. And it's possible to take that pattern and develop a formula for each term of an arithmetic sequence. And we're going to start with our first term as A1, and then our common difference will be D. So I'm going to use this table to help me figure out what that formula is. And as I go through this table, sometimes students see the way that this information is organized and they totally get it and it clicks. And sometimes this table is more confusing than it is helpful. So even if I get all the way to the end of the table and you're still not real clear on what's happening in this table, it's okay. The table's helping us come to the formula that we're going to be using in our next set of examples. Okay? So let's just say that I have a sequence here. I have 55, 49, 43, 37, and so on and so on and so on. So since my sequence is starting at 55, I'm going to call that first term A1. My second term is A2, and then A3, and then A4, and so on and so on and so on. And if we have a generic term that we don't know what number term it is, we call that A sub n. So n is like a variable that stands for any spot in the sequence. Now, how do I get this sequence? What's the pattern or the common difference that I'm using? To go from 55 to 49, I would have to subtract 6. To go from 49 to 43, I would have to subtract 6. To go from 43 to 37, I would have to subtract 6. So that's my pattern. That's my common difference. Now, really, in this first spot, I'm not doing anything. I'm not subtracting anything because that's the number that I'm starting with. And for here to fill in this part of the table, I'm not really going to worry about that. I'm not going to fill in that n part of the table for now. But now I do want to think of how I could express this sequence with numbers. So what I'm really doing to go from 55 to 49 is I'm taking 59 or 55 and I'm subtracting 6. So I'm really doing 55 minus 6 to get that 49. And we could even think of that as 55 plus a negative 6 if we wanted to. And I want you to think of it this way because the formula that we're going to be using and forming has a plus in it instead of a minus. So I want you to think of it with that plus just for now. Now, what I'm doing to go from 49 to 43 is I'm taking 49 and I'm subtracting 6. But I want you to think of it in terms of this very first term that we're working with. So if I started at my first term and I wanted to go all the way to this third term, I would have to subtract 12. I'd have to do 55 minus 12 to get 43. And remember, that's the same as 55 plus a negative 12. Okay, and then what would I have to do to 55 to go all the way to 37? Well, I'd have to subtract 6 and then subtract another 6, so that's 12, and then subtract another 6, so that's 18. So to go from 55 all the way down to 37, I'd have to do 55 minus 18, which will get me 37. Stop, mouse. And again, we could think of that as 55 plus a negative 18. Now, in this first part, to go from like 55 to 55, I didn't do anything. That was like 55 minus 0 is 55. But remember, I want to think of it like a plus. So 55 plus a 0 is how I want to think of that. Okay, now we're going to see if we can identify ways that I can rewrite the 6 and the 12 and the 18 so that I can start forming my pattern that I'm going to get in my next part of the table. Okay, now I'm sure you understand how I got the 6, just because I did 55 minus 6 is 49. How did I get the 12? Well, I subtracted 6 2 times. So that's kind of like taking 55 and taking 2 times a negative 6. I'm subtracting 6 2 times. Negative 6 times 2. And then how did I get that 18? Well, I subtracted 6 3 times. So that's like 55 plus 3 times a negative 6. Now here, if I was going to rewrite this part in this second little box, I really didn't multiply the 6 by anything. I multiplied it by 1. So that would be 55 plus 1 times a negative 6. And then in the first part of this table, or this row, I added a 0. So in order to get a 0, I'd have to multiply the negative 6 by zeros. So that would be 55 plus 0 times negative 6. So now what I want you to notice when the pattern is written this way, keep in mind that they're all equivalent. This 55 minus 0, or 55 plus 0, or 55 times, or plus 0 times negative 6, they're all the same. They're all equivalent expressions. But what I want you to notice is that this, the way it's written in green, I have a 0, and then I have a 1, and then a 2, and then a 3. What is that? What is the 0 and the 1 and the 2 and the 3? Notice that I have my first term here and a 0 here. I have my second term there and a 1 there. Third term and a 2. Fourth term and a 3. So I'm taking the number of the term that I have, I'm taking the n, and I'm subtracting 1. So really the way that we could rewrite this nth box here is 55 plus n minus 1 times a negative 6. Now again, this might be the point where you're starting to get a little confused, but this is really where the formula comes from. So just hang tight. Once we get to this final box in this final row, that's going to be the formula that we're going to be using. Now, I don't want to always have to write my equation with 55s and negative 6s and all that good stuff. So the 55, remember, that's my first term. That's my A1. So this is really A1 plus 0. And that -6, that was my common difference. So that's a D. And then I have my 55 and the 1 times D. And my 55, which is the A1, and the 2 times D. So I'm rewriting those expressions in green from up above with my symbols for my first term and my common difference. So now here we go. We're getting to the final piece. My equation that I'm going to use for any geometric sequence is going to be this. My first term plus, now I'm not going to write it as 0 and 1 and 2 and 3. Remember, I'm going to write that as the n minus 1. So I'm going to have n minus 1 times the -6, which is my common difference. So that's where this equation comes from. That's how I can take any sequence and work it into the formula or the equation for an arithmetic sequence. Now I have this on the next page. It's all written out very nicely here. So to find the nth term of an arithmetic sequence, we use this formula. So this is the formula that we came up with in that table. This is the formula that we want to use. And this a sub n, that's just your given term. Let's try that again. Don't know why that moves sometimes. Okay, so this is your given term. And that means that this is whatever term you're trying to find. It could be your 5th term, it could be your 8th term, it could be your 58th term. A1, we know now, that's our first term. That's the term that you're going to be starting with. It's the first term in your sequence. Why does it move around like that? That's really annoying. Okay, so that's our first term. The D, that's your common difference. So that's what you're adding or subtracting to go from one term to the other. And then the little n in here, that is the number of terms. So they might tell you you have so many terms in your sequence, or it could be the number of the term that you're trying to find. If you're trying to find the 5th term, that would be the 5 that you would put in for the n then. Okay, so let's try writing an equation using that formula. So for example 3, we're going to write the equation for the nth term of a geometric sequence. Now they're always going to give you the sequence to start with. So here we have the first 4 terms of a sequence, 8, 17, 26, 35. And we're going to start off just like we did before. I'm going to ask myself, okay, what am I doing to go from 8 to 17? From left to right. And to go from 8 to 17, the numbers are getting bigger, so I must be adding, and I'm actually adding 9. And then double check it. 17 plus 9, yep, that'll get me 26. 26 plus 9, yep, that'll get me 35. Okay, so that 9 now, that's going to be my common difference. That's my pattern. And I know my first term, I know A1, my sequence started at 8, I know that. So let's see if I can substitute some of this into this formula up above now. Now I'm trying to find the nth term. So I'm going to leave the n in the equation. So I'll have my a sub n. My a1 is 8. My d, yep, my d is 9. And then I'll have the n minus 1. I don't know what the n is. I want to leave the n in there. So that way if somebody says, hey, tell me the 15th term, I just plug in 15. Now I can simplify this a little bit. I can distribute here. So I'll have 8 plus 9n minus 9, and then I can combine my like terms. So I'll really have 9n minus 1. So that would be my equation for any term in the sequence that I was given. Okay, so let's try it again for part B. Again, I'm going to look at my pattern of or look at my sequence from left to right, see if I can figure out the pattern. How am I going from -8 to 6? I'm adding 2 because I'm getting bigger. How am I going from -6 to 4? Again, I'm adding 2. So that's going to be my common difference. I'm adding 2 every time. And my first term is a -8. Okay, so now I'm going to go to that formula. I'm going to leave the n in there. Let me scooch back up so we can see it. Then I have my a1 term. Well, that's a -8. Plus the d, that's my difference, times n minus 1. And then I'm going to distribute and combine my like terms. So I'll have -8 plus 2n minus 2. And then I can combine the 8 with a -8 and then a -2. So my equation will be 2n minus 10. Now, this format that these equations are written in is very similar to slope-intercept form. Slope-intercept form is y equals mx plus b. And that m is going to be your slope, that's a number. And then the b is what's added or subtracted on at the end, that's also a number. And then x is always going to stay an x. So hopefully you can see that this would be your m, the 9 would be your m, and the -1 would be your b. The 2 would be your m, and the -10 would be your b. So it's very similar to slope, this concept of arithmetic sequence. Okay, we have example 4 and example 5, and then we're done. Now these problems are thinkers, okay? Example 4 says, given the equation a sub n equals -2n minus 1, find the first 3 terms of the arithmetic sequence. So I want to find my first term, and my second term, and my third term. Now, this first term and second term and third term, this 1 and 2 and 3, that's actually telling me what I'm going to substitute in for the n. If I'm finding my first term, I have a sub 1 instead of a sub n. So I'm going to put a 1 in where the n is in the equation. So I'll have -2 times 1 minus 1. That's going to get me -3. And then if I'm trying to find my second term, I'll have a sub 2. So that 2 is going to go in where the n is. So -2 times 2 minus 1. So it's a -4 minus 1. That's a -5. And then the 3, I'll have -2 times 3 minus 1. So -2 times 3, that's -6 minus 1. That's a -7. There's the first 3 terms in my sequence. And notice that they're following the same pattern. We're subtracting 2 every time. And you can also use this formula to find the common difference if you don't know it. So this is kind of a cool application of these types of problems. So there are 5 numbers in a sequence. The first number is 5, the last number is 13. Find the second number. Okay, we can go back to the beginning. There are 5 numbers in a sequence. 1, 2, 3, 4, 5. I'll just put little spaces, like little blanks that we're going to fill in. The first number is 5. Okay, there's my first number. The last number is 13. Okay, there's my other number that I can fill in. Find the second number. Okay. Now, there's a couple different ways that you could do this. You could try and figure out what you had to add every single time so that you got all the way over to 13 from 5. So 5 plus something, plus something, plus something, plus something has to equal 13. And those little plus somethings, they have to be the same every single time. So you could do that, or you could use our formula. Okay? Now I'm trying to find the difference. I know my first number and my last number. Okay, now if I have my equation, it's a sub n equals a sub 1 plus the difference times n minus 1. Now I know my first term is 5, and I know my nth term, the last term that they gave me is going to be my nth term, that's 13. Now what term is the 13? Well, here's my first, my second, my third, my fourth, my fifth. So a sub 5, here's a sub 1, this is a sub 5, is 13. So that means this n is actually a 5. So I'm going to substitute a 5 in there. So now I can work through this and I can actually solve for d. So 5 minus 1 is 4, so that's a 4d. If I subtract the 5, I'll end up with 8. And then when I divide by 4, I'll get my common difference is 2. Now I'm going to double check that with my other method. What's 5 plus 2? That would be 7. And 7 plus 2 would be 9. And 9 plus 2 would be 11. And 11 plus 2 would be 13. Look at that. Now we can fill in the whole sequence. So there's a variety of different ways that you can use that equation or that formula for the arithmetic sequence. You can use it to find the first term or the last term or the difference or the variable n. So it has a lot of applications. So I have one last question for you. How do you know that this sequence 4, 5, 7, 10, 14 is not a sequence? So let's take a look at it. What are we adding as we go from left to right? What are we adding to go from 4 to 5? We're adding 1. What am I adding to go from 5 to 7? I'm adding 2. And to go from 7 to 10, I'm adding 3. To go from 10 to 14, I'm adding 4. So it's not a sequence because I'm not adding the same amount every time. The only time we have a true geometric sequence is if we're adding a constant number every single time. Now, this is still a type of a sequence, but it's not going to be an arithmetic one. Okay, an arithmetic sequence, you have to add or subtract, and you have to add or subtract the same amount every single time to go from one number to the other in the sequence. So your homework for tonight is a arithmetic sequence worksheet. There's not a section in the book on arithmetic sequences, so that's why we've given you the worksheet. Hopefully you picked one up in class. If not, they're on the class website, and you can go there and print one off. And if you have any questions on it, come on in and see me before school.